At 0300 local time, a fire ignited deep in the stern of the USS Gerald R. Ford, the most expensive warship ever built, and began burning through the compartment walls of a laundry room 13 decks below the flight deck.
Not a combat hit, not a missile, a laundry room.
The Ford had spent months absorbing Houthi drones and cruise missiles over the Red Sea, launching strikes, putting American air power over some of the most contested water on the planet. And now it was being gutted from the inside by a fire that burned for 30 straight hours, sent more than 200 sailors to medical with smoke inhalation, and left over 600 of them with nowhere to sleep. That ship cost $13 billion. The laundry room it couldn't survive cost less than the average American kitchen renovation. The fire was eventually put out. The Ford was still floating. But what came next is the part that nobody expected, and the part that reveals something much more uncomfortable than the fire itself. 5 weeks later, the USS Gerald R. Ford crossed back through the Suez Canal and re-entered the Red Sea.
Nuclear plant online.
Electromagnetic catapults armed. Strike sorties launching around the clock as if the previous 30 hours had been a scheduled maintenance drill. The standard response to a major internal shipboard fire is a withdrawal of more than 5,000 nautical miles back to a dry dock in Norfolk, Virginia, followed by months of controlled inspection, structural repair, and systems recertification. The Ford did not do that. What you need to understand first is what a fire actually does to a warship made of steel. In a house, fire consumes wood and drywall. In a 100,000-ton carrier built from HY high-yield steel, the physics change completely. The steel doesn't burn.
It becomes something worse. It becomes a conductor.
When compartment temperatures reach 1,000 degrees Fahrenheit, the bulkheads absorb that thermal energy and transfer it directly into every adjacent room. You don't need flame to cross a wall.
You need time.
The radiating heat from the steel alone triggers auto-ignition.
Paint combusts on its own.
Rubber insulation melts off electrical cables. Secondary fires start in rooms where there is no actual flame at all.
The steel is not burning. The steel is the fire.
To stop it, sailors have to establish fire boundaries, standing in unburned compartments and blasting the bare steel walls with continuous seawater, not to extinguish anything, but simply to extract enough thermal energy to keep the metal below the ignition point. They are not fighting the fire. They are arguing with the laws of thermodynamics and trying not to lose. On a U.S. Navy warship, there is no professional fire department to call. There is number 911 in the middle of the Red Sea. Every sailor aboard, the cooks, the mechanics, the aviation technicians, every one of them is a firefighter. Within minutes of the general quarters alarm, hundreds of them abandoned their stations. They strapped on self-contained breathing apparatus units, grabbed hoses, and descended into the dark. What followed was 30 hours of the most brutal work a human being can be asked to do. Damage control teams crawled through pitch-black, smoke-filled corridors using thermal imagers just to see their own hands. The temperature in the main fire zone turned their own hose water into scalding steam that cooked them inside their protective gear. Each SCBA tank gives 30 to 45 minutes of air before the low alarm screams. So the teams ran a relay.
Push in, fight, alarm sounds.
Trace the hose back out by feel in zero visibility.
Swap tanks, do it again. For 30 straight hours.
They dragged water-filled hoses up and down narrow vertical ladder wells. They waded through knee-deep pools of salt water, chemical fire suppressant, and the constant live threat of high-voltage electrical cables sparking underneath them. They are the only reason the fire never reached the aviation fuel lines. If it had, the Ford would not have been a fire story.
They won.
But the cost was immediate and visible. Several berthing compartments were gutted. Over 600 sailors had nowhere to sleep, dragging whatever blanket survived onto the hard steel floors of the mess decks and hangar bays. The ship was alive. It was not whole. 300 nautical miles to the northeast, in the Arabian Sea, the USS Abraham Lincoln held station. Too far away to cover the Red Sea gap the Ford had just left. A replacement was coming. The USS George H.W. Bush had departed Norfolk, but it was routing the long way, around the Cape of Good Hope, up through the Indian Ocean, deliberately avoiding the exact missile threat the Ford had been absorbing for months. It would not arrive for weeks. The clock was running. The Red Sea had no American air cover, and the Ford was sitting in the Mediterranean with a scorched hull and 600 sailors sleeping on steel. Days after the fire was extinguished, the Ford docked at Naval Support Activity Suda Bay in Crete, Greece, approximately 1,000 nautical miles northwest of where the fight was happening. What happened next is something only one Navy on the planet can do. The Forward Deployed Regional Maintenance Center, the FDRMC, is not a shipyard. It has no dry docks. It has no cranes rising above a harbor. It is a deployable logistics network headquartered in Naples, Italy, with detachments scattered across Europe and the Middle East, and its entire purpose is built around one philosophy. If the ship cannot go to the shipyard, bring the shipyard to the ship. The moment the fire was out, Tiger teams activated. Rapid response units built from Naval Sea Systems command engineers and civilian contractors flew immediately to the Mediterranean carrying specialized diagnostic equipment. They boarded a smoke-scarred warship not to clean it, but to determine whether it was structurally safe to put back in a war. This is the part that cannot be rushed and cannot be faked. HY-80 steel under extreme heat does not simply cool back down to its original state. The quenched and tempered crystalline structure that gives the steel its load-bearing integrity can fundamentally change under sustained high temperatures. You cannot see this with a flashlight. You cannot find it by knocking on the wall. Engineers deployed ultrasonic scanners and magnetic particle inspection equipment to map microfractures hidden inside bulkheads that looked perfectly intact from the outside. They also had to trace the entire secondary electrical distribution system, every meter of cable running through the affected zones, before anyone could safely certify that the Ford's A-1B nuclear reactors could resume normal operations. A melted cable junction in the wrong place is not an inconvenience. It is a cascading failure waiting for the worst possible moment. A Greek island became a shipyard in 72 hours. But fixing the steel was only half the problem. The fire had destroyed the living conditions for nearly a tenth of the crew. The laundry facility was ash. Personal lockers were gone. 600 sailors needed somewhere to sleep. And here is where the story takes a turn that sounds like fiction until you check the procurement records. Nearly 1,000 mattresses were physically stripped from the future USS John F. Kennedy, CVN-79, a multi-billion-dollar sister ship sitting unfinished in a shipyard in Newport News, Virginia. Those mattresses, along with replacement clothing and personal gear, were loaded onto cargo aircraft and flown across the Atlantic and across the Mediterranean to reach a warship anchored off Crete. The U.S. Navy cannibalizes its own future to keep its present in the fight. That is not logistics. That is a decision that someone in Washington signed off on and then hoped no one would notice. After Crete, the Ford made a final stop at Split, Croatia, for 10 days of additional port work. Then the surgery was declared complete.
Not finished, complete enough.
5 weeks after the fire started, the Ford crossed back through the Suez Canal. What the Houthis did not know was that the ship returning to the Red Sea was not the same ship that had left it. It was a ship that had been field repaired at speed, with structural inspections conducted under time pressure, systems recertified on an accelerated timeline, and structural risk assessments that accepted unknowns in exchange for urgency. The Ford was back in the fight. The question of what was still hiding in the steel had been managed, not eliminated. The A-1B nuclear plant was untouched by the fire. The electromagnetic aircraft launch system, EMALS, was operational, a linear induction motor that stores roughly 122 megajoules of energy and releases it in a single controlled pulse to accelerate a 60,000-pound fighter from 0 to 130 knots in under 3 seconds. The Combat Information Center was fully staffed. Strike sorties were launching around the clock over the Red Sea within days of re-entry. Adversaries watching the Ford return got the message clearly. Even when this ship is wounded and its sailors are sleeping on steel, it can still put armed aircraft over your position. Deterrence is not subtle. It is not supposed to be, but deterrence has a cost, and the cost of what came next was already accumulating in the background while the Ford was being patched in Greece. Because no replacement carrier was available to take the Ford's place, the ship was forced to remain on station for nearly 300 days. The longest continuous U.S. aircraft carrier deployment in the post-Vietnam era. That number is not a record to be celebrated. It is a measurement of how badly the math had broken. The U.S. Navy runs on a planning cycle called the Optimized Fleet Response Plan. 1/3 of carriers deployed. 1/3 in deep maintenance. 1/3 training and preparing for deployment. 36 months per rotation. It is not an arbitrary schedule. It is the maintenance interval that the engineering tolerances of these ships were designed around.
Sprint hard, return, reset in a shipyard, repeat.
The Red Sea broke that cycle completely. And physics, which does not negotiate, sent the invoice. EMALS does not wear evenly across a deployment. Every electromagnetic pulse that launches an aircraft generates immense thermal and electrical stress on the stator coils and high-voltage switching equipment. Thousands of launches over 300 days means electrical arcing that pits the power conversion surfaces and thermal expansion cycling that threatens the alignment of the linear armature. Engineers on deployment were cannibalizing parts from backup power conversion systems to keep the primary launch rails operational. The ship was eating its own spare parts. The Advanced Arresting Gear, AAG, the system that catches returning aircraft by absorbing millions of foot-pounds of kinetic energy through a water twister and induction motor, degrades with every trap. Cables stretch. Hydraulic dampeners wear. The water itself superheats under continuous cycling. Over thousands of arrested landings without a shipyard reset. The margins that keep a 60,000-pound jet from running off the end of the flight deck become numbers that engineers watch very carefully and try not to discuss in public. Underway replenishment made it worse. Every resupply required 2 massive ships sailing perfectly parallel at 15 knots, separated by 150 feet of open ocean, connected by high-tension steel cables with hydraulic tensioning winches managing the slack in real time. The extended deployment pushed those winches and tensioning systems past their rated thermal and mechanical limits. Seals degraded. Heavy-duty motors burned out on the supply ships themselves. By refusing to leave the Red Sea, the Ford did not just exhaust its own crew. It stretched the entire global support chain to the point where the ships keeping it alive were beginning to break down as well. The Ford was fighting the Houthis. The US Navy was simultaneously fighting the laws of physics. And the laws of physics do not blink. At 0600 local time on the final day of the deployment, with the Ford finally heading home, the real accounting began. 30 hours of shipboard firefighting. A field repair conducted on a Greek island with structural assessments made under time pressure. A Croatian port as the final check. The future Kennedy stripped of 1,000 mattresses. MLs arcing on launch number several thousand over a 700-kilometer transit home. AAG dampeners degraded past the maintenance threshold. Supply ship winches burned to their mechanical limits. The Ford made it back to Norfolk. And then the dry dock inspectors went inside. What they found in the bulkheads, in the cable runs, in the structural steel that had been ultrasonically scanned under a deadline in Crete, took months to fully assess. The fire in the laundry room was not the enemy.
It was the symptom.
A carrier on a standard rotation cycle gets inspected and reset on schedule. Systems that approach where limits get replaced before they fail. A laundry room fire on a well-rested ship in a standard maintenance cycle gets caught in minutes, not fought for 30 hours. The fire was the invoice for 300 days without a shipyard. The forward repair in Greece was brilliant. The return to combat was genuinely impressive. No other navy on the planet could have done either of those things in that time frame. The Chinese Navy would have had to withdraw to its home port. The Russian Navy would have abandoned the theater entirely. The US Navy turned a Greek island into an emergency shipyard in 72 hours and had the ship back in a combat zone in 5 weeks. That capability is real. That capability is earned. That capability took decades and extraordinary investment to build. But capability and sustainability are not the same thing. The optimized fleet response plan was built on a promise.
1/3 fights, 1/3 heals, 1/3 trains.
When that math breaks, everything downstream breaks with it.
The steel, the electronics,
the sailors. And eventually, if the cycle stays broken long enough, the fleet itself. The damage control teams who crawled through the dark for 30 hours, breathing through tanks that lasted 40 minutes, wading through electrified saltwater to save a $13 billion ship, they did everything right. They held the line. They deserve every word of credit they will never fully receive. But they should never have had to fight that fire. The field tourniquet in Greece was extraordinary. It was also a tourniquet. The patient eventually needs surgery. The question that no one in Washington is comfortable answering out loud is how many times you can perform battlefield surgery on the same patient before the patient stops responding to treatment. The Ford is back in Norfolk. The math is still broken. The Red Sea is still there. If you enjoyed this video, check out our other video on the weapons the Houthis used to keep the Ford on station for 300 days. Bye for now.